The other two operations that we can do and using numbers in scientific notation are adding and subtracting. Now, adding and subtracting is a little more difficult. It can be easy if the exponents are the same, but if the exponents are different, before we can add or subtract the numbers, they have to have the same exponent or the same power of 10. So we're going to look at 4 examples. 2 examples will be an addition example where the exponents are the same, example 1, and example 2 is a subtraction example where the exponents are the same. And in example 3, we're going to do an addition example where the exponents are different, so we have to adjust one of the exponents to equal the other. And example 4 is a subtraction example, once again with different exponents. Okay, so here's our 2 rules here. First one is if the exponents are the same, we're in a great situation. It's real easy. Really only one step. We just add or subtract the base numbers and we keep the exponent. Very simple. That'll be example 1 and example 2. If the exponents are different, however, we have to you can either make the smaller exponent equal to the larger exponent or vice versa. I have found it's much easier. It eliminates a step at the end if we make the smaller exponent equal to the larger number. Okay, and we're going to use LARS again there. Remember, if I move my decimal left, I'm adding to my exponent. If I move my decimal right, I'm subtracting from my exponent. Okay, so let's look at example 1. We have 2.56 times 10 to the third plus 6.964 times 10 to the third. Looking at my exponents, they're both an exponent of 3, so I don't have to change anything. All I have to do is add the base numbers, and my final answer is times 10 to the third. So I use my calculator, 2.56 plus 6.964, and I get 9.524. So let's write that here, 2.56 plus 6.964, and that gave me 9.524. And all I do is keep my exponent. So my final answer is 9.5, if I'm rounding to the nearest tenth, 9.5 times 10 to the third. That's it. Okay, example 2, 8.96 times 10 to the 7th minus 3.41 times 10 to the 7th. Once again, exponents are the same. So I go to my calculator and I do 8.96 minus 3.41 gives me 5.55. So I write that step, 8.96 plus, not plus, minus, that's a minus sign there, subtraction, 3.41, and that gives us 5.55. So if I want to round to the nearest tenth, I could say 5.6 times 10 to the 7th. So I keep the same exponent. 2 easy examples there. If the exponents are the same, makes our life easy. Okay, now the 2 harder examples. Example 3, we have 2.46 times 10 to the 6th plus 3.476 times 10 to the 3rd. Okay, so we look back at our second rule here. If the exponents are different, we want to make the smaller exponent, which would be the 3, equal to the larger exponent, which is 6. So what we're going to do is we're going to keep this first one the same, 2.46 times 10 to the 6th. And we're going to be adding there, okay? So now I got to ask myself, what do I have to add to 3 to get to 6? Well, I add 3, so if I'm adding 3, I'm moving my decimal left 3 times. So I could, maybe if I put this number right here, 3.476, okay? And I go 1, 2, 3. And in here I put my zeros. Okay, so now I could rewrite this 2.46 times 10 to the 6th plus, and now I have 0.003476 times 10 to the 6th. Okay, now my exponents are the same, and I can just go back to adding the base numbers, and I go on from there. Okay, so I could do 2.46 plus 0.003476, and I get, if I wanted to round, I could say 2.5. So 2.5 times 10 to the 6th. And that's my final answer. Okay. All right, look at our subtraction example. 5.762 times 10 to the 3rd minus 2.65 times 10 to the negative 1st. Once again, make the smaller exponent equal to the larger. Okay, so I want to rewrite 5.762 times 10 to the 3rd. And now I'm going to subtract here. And once again, ask myself, how do I go from -1 to 3? Well, I add 1 to get back to 0, and then I add 3 to get to 3, so I have to add 4. So I have to move this decimal 4 times to the left. Okay, so I'll write over here to give myself some room, 2.65. And I'm going 1, 2, 3, 4 times to the left. Add in my zeros there. So I have 5.762 times 10 to the third minus 0.000265. And now that is times 10 to the third since I moved my decimal. Now I subtract 5.762 minus 0.000265. And I get 5.76, 1735. I can round to the nearest tenth if I want. 5.8 times 10 to the third. That is my final answer. So just remember, when we're adding and subtracting in scientific notation, our exponents have to be the same. If they're already the same, our life's easy. We just add or subtract the base numbers and keep the exponent. If the exponents are different, remember it's much, much easier to make the smaller exponent equal to the larger using LARS. If I move to the left, I add, right, I subtract.